let's try this problem. So evaluate the expression. Okay, so we've got log base 2 of 32, and we want to know what that equals. Now, I know it can be difficult when you see something like log base 2 of 32, or let's say we're log base 2 of 16. You're not sure what to do. We're not used to evaluating expressions or logarithmic expressions, okay? Because they don't come up usually until high school, all right? However, let's just think about a basic expression that you could evaluate. If I said, what's 2 times 3? Evaluate 2 times 3. You would say, oh, well, that's 6, right? And if I said, okay, well, evaluate 2 to the third. You would say, oh, okay, well, that's just 2 times 2 times 2. And that's just going to be 8. Right? No problem there. Okay. Well, we can do the same thing here, but what we can do is when I used to teach kids to evaluate expressions, some of them had difficulty the first time around saying, well, I'm not sure, what 2 times 3 is. Usually it was powers and stuff that would create more difficulty. And I would say, well, you can think that we're trying to solve. So let's say that 2 times 3 equals x. Okay? So then you say, okay, well, 2 times 3, well, that's 6. Okay, and that's going to equal x. Okay, so then x equals 6. Okay, maybe I'll just do it in the red here. Yeah. X equals 6. And then they'd be done. But I would say, okay, well, I don't want to see the variable there. So I'd say once you're done, get rid of the x and just write it as the value, okay? But some students liked the idea of having a placeholder. 2 times 3 equals some value, and then they kind of go through and then they get that value, and I say then just eliminate the variable after. So you can do the same thing with 2 to the third, okay? You could say, okay, well, 2 to the third equals some value x, and I want to know what that is. So 2 to the third is 2 times 2 times 2, so that's going to be 4 times 2, which I forgot to write up there, is equal to x. Okay, and then 4 times 2 is 8, and that is equal to x. Boom, and then we could say, okay, so x equals 8. Switching these markers is tough. X equals 8. So then I would always say, get rid of the x, and you're going to write it as just 8. I know I had to move up there, okay? So I know some of you may not do this approach, but I do know I have done this approach with some students. They feel like they want it to equal a variable so then they can find a value, and that's totally fine, as long as in the end you eliminate it because it was just evaluated, just wanted the value, okay? We didn't want a variable in it at the end. But we can use that same approach to this. So let's say that we said that this equals x, okay? Because it equals some value. We want to know what that value is, okay? So, what we're going to do, okay, is we are going to now say, all right, let's write this in exponential form, because it doesn't necessarily help me just yet, but if I write it in exponential form, it will. So remember, exponential form of this would be 2 to the x, okay, equals 32. Okay, so 2 to the x equals 32, all right? So now I can easily figure out what x is, right? I just want to know what power do I raise 2 to get 32? So if we think about it, okay, well, I can kind of come over here and say, okay, so 2 to the first is just 2. 2 squared is 4. 2 to the third is 8. Okay, I'm getting closer. 2 to the fourth is 16. And then 2 to the fifth is 32. Okay, so I need to raise 2 to the fifth power to get 32. Okay, so I say 2 to the fifth power equals 32. Okay, so then obviously in this case, x equals 5. So you can write it out as x equals 5, okay? But I don't want to keep my variable in there. It was fine to use it as a placeholder and say, okay, 2 to the what equals 32. Well, I know that's 5, so I know the what is 5, so x equals 5. Okay, so this equals 5. So then what you would just do is you could either rewrite the whole logarithm or just write the answer. Where did the thing go? Whoops. Okay. So you could rewrite the whole logarithm and say log base 2 of 32 equals 5, because remember, we discovered that x equals 5, okay? Because 2 to the what equals 32? 2 to the 5th equals 32. So log base 2 of 32 equals 5, or we could just sit here and write it as just regular old 5, okay? Either way. But for those of us that have trouble recognizing that, I think that it makes sense to actually put a variable in as a placeholder, solve for that variable, say 2 to the what equals 32. Well, that's going to be 5, so 2 to the 5 equals 32, so therefore this equals 5, x equals 5, and then that's what log base 2 of 32 is. It's 5. It's what power do I raise 2 to, okay, what power do I raise 2 to get 32? And that's 5, okay? So there you go.